at what are called telescoping series. I guess I could call it a telescoping series test, but it's a test because you use it in telescoping series. Isn't a geometric series test a test that you only use on geometric series, right? For example. So what does a telescoping series look like? Well, this is an example of a telescoping series. And we are interested in, does it converge or does it diverge? That's the only answer. So if it converges, we would like to know what number it converges to. And if it diverges, then that's the end of the story. And you might think that I'm going to do some kind of limit thing like we did, or a test that says if R is bigger than 1. No, this is going to be done a different way. What you do is you say essentially plug in 1. So you get the square root of 1, take away square root of 2. And then you add the next term, which would be 1 over the square root of 2, take away 1 over the square root of 3. And then you add the third term, which is 1 over the square root of 3, take away 1 square root of 4, plus dot, 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 dot. And then you finish on essentially the nth term, I'll call it. So what I've really just written down here is what the partial sum Sn would be, right? It would be the first term plus the second, plus the third, fourth, the fifth, and then we'll finish on the nth one. And now carnage is about to happen. In a telescoping series, almost all the terms get killed off. So let's see what happens. Would you agree that negative a half gets killed off later by that plus 1 over root 2? Won't that negative 1 over root 3 be killed off with that plus 1 over root 3? Wouldn't that guy be killed off with the guy that would be here? And wouldn't all the guys in the middle be killed off? A bit harder to see, but see this guy here, won't he be killed off by a fellow that would be there? The result is that everybody in the middle kills each other off, and all I'm left with are those two terms. Agreed? So the partial sum, what you would get if you added up the first n of these terms, would be the guy at the beginning and the guy at the end. Now, what happens when n goes to infinity? What happens to that partial sum? Well, would you agree you can just brute force it? Won't you get 1, take away 1 over infinity, which is 1, take away 0, which is 1. Now, if the partial sums have a limit, doesn't that mean the series converges to that limit? So we're finished. This guy converges. Converges to 1. So when you're doing a telescoping series, write down the first 2, 3, 4, 5, 10 terms, whatever it takes you to be sure you know what the heck's going on. And then you get some pieces left over, and then you can figure out what to do. Let me try another one. And by the way, that one there is similar to question 9. Let's do one. Let's do one like this. Telescoping series all look like this. Something take away something, and the two things look similar. Would you agree these are very similar looking fractions? These are very similar looking square roots. A telescoping series won't look like 1 over n take away e to the n, right? The two pieces are essentially just versions of each other shifted a little bit. Okay? This one's plus 3, this is an n. Actually, let me change that to plus 2 or we'll be here all day. So if you write down the first term, you get 1, take away a third, If you write down the next term, it's 2 take away a quarter. The next one is a third, take away a fifth. The next one is a quarter, take away a sixth, dot, 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 dot. And then you finish on this guy. Now, wish I hadn't put those dots there because I want this one. That's the last term. Now it gets a bit trickier. What would this term be, the one just before that? Well, it would be 1 less than that, so it's 1 over n minus 1, and it'd be 1 less than that, so that would be take away 1 over n plus 1. You might think, why do I need that? Well, let's see what's going on. That guy stays alive. Do you agree? There's nothing that comes later that's going to kill that one. Won't that guy get killed off later by that one? Right, the next term is a half. Does that half get killed off by anything that comes later? Does it look like there's any more chance of a half happening? And the answer is nope, that one's going to make it. Now, what about this fella? He gets killed by that one. What about this fella? Can you trust me? He gets killed by that one. What about this guy? He gets killed off. So what we have here are 2 terms at the beginning that survive. Everything else in the middle kills each other off. And then you get to the guys at the end. This fella will remain alive. This guy would eventually get killed off by a guy that would be here. This guy remains alive. And this guy would get killed. The way I tend to remember it is that if 2 guys at the front live, you see these 2 guys are at the left-hand side, the front, then 2 guys at the end will live as well, because everything else kind of matches. Now, do you see that partial sum consists of 4 terms? The 2 numbers at the start and 2 terms at the end, right? 2 terms at the end, 2 terms at the start. Right, would you agree that this can be done by brute force? So you get 1 plus a half, take away 1 over infinity, take away 1 over infinity, 3 halves. So we now know that this one converges to 3 halves. So let me say that one last time. When you're doing one of these and you write them all down, if 2 terms at the beginning, right, the first term survive, then 2 terms at the end will survive. God forbid you ever get one, but can you imagine a question where the first term, that first term, and this first term all survive, right? They don't get killed off by anything, right? So that one survives, can you imagine this one survived, and let's say that one survives. Won't the last 3 guys, the one here survive, the one here survive, and then I'd have to figure out what goes here, and that one there would also survive. So you'd have 3 guys at the beginning, take away 3 guys at the end. Does that make sense? How you structure that. Now, let's show you a telescoping series that diverges, right?
I have a quick question.
Yes.
Where did you get n minus 1 from? I seem to have missed that.
This guy here?
Yeah.
Yeah. What I did, I'll show you this one first, is I took 1 away from this guy. So 1 away from n plus 2 gives me n plus 1. And I took 1 away from the n to get that one.
And why did you do this?
That would represent me taking the value 1 to the left of this one, 1 smaller. So that becomes 1 smaller. Now, if I wanted to do the next one, then I take 1 away from that, which would get me 1 over n. And I take 1 away from that, which could get me 1 over n minus 2. And that's what the third one would have been. You could keep working backwards, but typically you normally just need to do 2. In a very rare occasion, you might have to do 3.
Okay, that helps a lot. Thank you.
Right. So let's show you one divergent, right? So let's suppose I did sigma n equals 1 to infinity, e to the n plus 1, take away e to the n. And I'll set up my SNs, and you plug in 1, you get that. You plug in 2, you get that. You plug in 3, you get that, and you keep on going. And I'm going to plug in that one as my last guy. So let's see who gets killed off here. Does E squared get killed off? Is there an E squared somewhere? Yes. Does e to the 1 get killed off? Is there anything here that's ever going to be an e to the power of 1? Would you agree that makes it? Right. Will e cubed get killed off? E to the power of 3. Right. Can we just assume that once you reach a point, you know everybody's going to die, right? Everybody comes after. So that one would kill off with somebody there. Now, have you noticed that in this case, the second one made it? Which one of these two would survive then? Because one of these will get killed off and one of these will survive. Which would survive in this case? If that one died, which one would be from here?
E into the plus, or E to the n plus 1.
Right. Do you see that you can look at shapes? Do you know if the second one dies, if the second one lives, doesn't the first one here live, right? It's a kind of matching thing. Now, look at what's left in this telescoping series. Only 2 terms. But if you do the limit as n tends to infinity of this, don't you get e to the infinity, take away e, which is infinite? That means this guy diverges. Are we good with that? So a telescoping series test is basically used on telescoping series only. And you write down the first 4 or 5 terms and you kill everybody off and you see what's left at the beginning and you see what's left in the end. And then you can take the limit of what the partial sum looks like. And if it's a number, it converges. And if it's infinite, it diverges. That's essentially a process. So there's one little hiccup left. You will, hopefully not too often, but you will see questions where they will tell you it's a telescoping series. That's good, but it won't look like one. And this is a version of question 10. And I'm only going to do the first part of this. That guy is not a telescoping series yet. It's not 2 things subtracted. That guy, here's a word you haven't heard in a while, partial fractions. You remember having to integrate functions and do partial fractions. Can you remember the cover-up method? That's the guy you're going to have to use. So here's a bit of something you've not seen in a heck of a long time. This is going to be split into 2 fractions. A over n, I know that's going to be negative, but right now we'll call it plus b over n plus 1. And for those who got me in Calc 2, you know the cover-up method. If you came from someone else, you would probably know, not probably, you will know the general algebraic method. If you like that method, keep doing it. But here goes. I want to know the number that's a. I go over here and I cover up that n, right? I then use 0 in the fraction that's left. The reason I use 0 is you want to make this term 0. And what makes n 0? N equals 0 makes n 0. And if you plug that into what's left, you have 18 over 3. And 18 over 3 is 6. And that's called the cover-up method. Is it ringing some bells how that worked? Right, let's get the n plus 3 term. If you cover up the n+3 term, what value of n do I now use in the fraction that's left? The value that makes n+3 0. And isn't that -3? And 18 over -3 is -6 over n+3. There you go. You now have a telescoping series, and that'll converge, and it'll converge to something, and you'll find out what. Are we good with that one? Here's another different situation. It is a telescoping series, and they tell you it's a telescoping series. It just doesn't look like one yet. To be a telescoping series, shouldn't it be A take away B, right? Something like that. Any ideas of how to rewrite this guy so it looks like something take away something? Seven natural log of n divided by n+1. How could I rewrite that as a subtraction?
Put it into two different natural logs.
Right, can I put a little bracket around it and call it that guy? Take away that guy. Does that make sense? I don't like that 7. You know, actually, I'd probably pull the 7 out of the sigma here. I like to do that. There. Would you agree that's a very nice telescoping series that you should be able to prove? That's me finished with telescoping series. Any questions before we return to some geometric series that are a little bit more difficult?
Can you do another one that diverges?
Okay. Let's do this one then, since it's set up. So I had this guy, I turned it into that. I did this just to make it look pretty. So let's find what this one does. Oh, let's put the 7 in, because some of you might not like. Yeah, that's what it looks like. All right, you plug in 1. So you'll get 7 log 1, take away 7 log 2. And then the next term is going to be 7 log 2, take away 7 log 3. And the next one's going to be 7 log 3, take away 7 log 4. And you could keep doing that forever, but we will finish at 7 log n, take away 7 log n+1. Okay, does 7 log 1, does that live? Does there look like there's anything that's going to have a log 1 in it? So I'm saying you live. Won't that 7 log 2 get killed off with that 7 log 2? Won't that 7 log 3 get killed off by that? At this point, I'm pretty sure everything dies. Now, one term at the beginning, which one of these two then is going to live? If that one survives, which one of these two will survive as well? The first or the second?
The second one.
Right. Now, can you see that these are the only two terms that would live after you've done the cancelling? Now, what's going to happen as n tends to infinity of this partial sum? Well, it's going to be the natural log of n tends to infinity of 7 log 1, take away 7 log n+1. That's actually 0. And that's 7 times the log of infinity. But isn't that infinity? And isn't 7 infinity is infinity? So I guess the answer is negative infinity, but we don't care if it's plus or minus. We just know that it diverges. So that would be another divergent one. Are you good on that one?
Yeah, that makes sense.
Right. So let's now move on to some geometric series questions that are not obvious. A quick recap of the geometric series. It's a series that looks essentially like this fella, AR to the n minus 1. A is the first term of the sequence, and R is called the common ratio. And the geometric series test says if the common ratio, the absolute value of it, is less than 1, it converges, and if it is greater than or equal to 1, it diverges. And when it converges, the formula for what the sum of it is, which is this guy, is A over 1 take away R. So that's the geometric series test in all its glory. So suppose you are given a sequence. There I go, say sequence again. Suppose you're given a series and there is no formula given. They just do that. And you're being asked, does it converge or diverge? And if it converges, find its sum, right? Find S. So what you do is you find those two guys. And I don't know why I put 1 there. Would you agree that the first term is always whatever that number is? Because wouldn't that be the first term, then you add the second term, then you add the third, then you add the fourth. So far, so good. So that would be essentially A1. Now, how do you get the common ratio? What do you multiply that to get that? What do you multiply that single digit to get that fraction? What do you multiply that one by? And if it's a geometric series, won't you be multiplying by the same thing each time? So if 5 is what A1 is, isn't -6 what A2 is, and isn't 36 what A3 is, and so on. So if you want to find a common ratio, just divide the first two terms, A2 over A1. In this case, -6, because that's part of the thing, over 5. Okay, so this is a geometric series. Its first term, A, is 5. Its common ratio is -6/5. The absolute value of its common ratio, would you agree that's bigger than or equal to 1? So what's your conclusion?
Diverges.
And that's the end of the story. You write in the big box that they give you, diverges. Okay, let's see if I can pick one that, how about this one? 10, take away 6, add 3.6, take away 2.16. You're told it's a geometric series, so you don't need to worry about how do I know if it's one. They just tell you in the question. Would you agree that A is the first term, 10? The common ratio is going to be those two guys. So that would be A1, that number there, the whole thing would be A2, that would be A3, this would be A4. -6 over 10 comes out to be -3/5. Are you happy about the common ratio for this one? Is -3/5. If you were looking at a geometric series that had this shape to it, I can tell looking right away whether it's going to converge or diverge without even calculating any of these, just by the numbers themselves. This one diverged. It went 5, -6, 36/5, and 216/5, whatever those are. This one went 10, -6, 3.6, -2.16. How do I know that this one was going to converge, but this one was going to diverge? Just by looking.
The second term's absolute value is greater or less than the first term's.
Right. Oh, and another way of saying that, Andy, isn't this getting bigger and bigger numbers? Forget about the plus minus part, right? And aren't these getting smaller? So if you're getting smaller in the geometric, you're going to converge, and if you get bigger. Now, since this one converges, you are expected to find out its sum. So it's going to be 10. 1 take away 3/5 is like 1 add 3/5. And if you want to do that in a calculator, just to be safe, 10 divided by a bracket 1 plus 3/5, and then just go math 1 and 25 quarters. So if you kept continuing this series, adding and subtracting, because it's an alternating one, you would end up with the answer being 25 quarters. Are we good? Now, let me show you some of the homework questions. Because one just came to mind that looks kind of cool. Is that big enough? Yeah, that's big enough. Right. Double check I hit the right one here. Okay. You're looking at question 16. Is that going to converge or diverge? Just looking. You don't need to do any number crunching in your head.
Converge.
Agreed. Aren't the terms getting smaller? Forget about plus minus. Are they getting smaller numerically? In this question here, what is A?
16.
What's the common ratio?
0.64.
In that question, isn't everything you need to know in front of you? You don't need to do any calculations. You are good. But look what they did in question 18. It is a geometric series. They tell you it is not obvious who A is, and it's probably not obvious who the common ratio is. Yet, nonetheless, it is a geometric series. And so we have to figure out how to get those two important values. Right, would you agree it looks nothing like, 3 times a half to the power n minus 1? Isn't that the way geometric series should look? Because then I can tell A and I can tell R without any trouble. You see, this does not look like it, right? So how am I going to figure out the two guys? Well, I'm going to put in n equals 1. And then I'm going to put n equals 2. And then I'm going to put n equals 3. I'm basically just going to write it down like it was a sequence from the earlier questions. Right. Remember the ones that we did where the numbers were written down for you? Do the same. Now, when I do it this way, is it pretty obvious that A is 6 over pi? And if I wanted to get the common ratio, tell me who I divide. How would I get the common ratio? What? Two numbers, one in the top divided by one in the bottom.
1 over
6 divided by pi squared divided by 6 over pi.
Right, so we do this guy divided by that. I hate fractions with fractions in them. So can I say it's the same thing as saying that, which then becomes the same thing as that? Are you okay with what I just did there? Now, cancel out the pi's and 6's, and guess what? The common ratio is 1 over pi. Are we cool with how I did that? You can't really do that in the fraction, because the minute you use pi, isn't the calculator just going to give you a decimal that you can't get out of? And we want an exact value. So it's 1 over pi. Stefan, you look puzzled. Are you puzzled, or is that just the way you're looking?
Oh, a little bit of both. I wasn't really sure about how you got the common ratio, but
Okay, here we go. That's A2.
Oh, wait.
That's
never
A1.
mind. Never mind. I see, because I had said 1 over pi.
Okay, you
Yeah.
see it now?
I now realize it simplifies down to 1 over pi.
That's it. So what we now need to do is, would you agree that 1 over pi is less than 1? So I know it converges, right? 1 over 3.14. So let's find out what it adds up to. It's A over 1 minus R. And you're going to have some style point issues here. In other words, we have to make the answer look pretty. Well, A is 6 over pi, 1 take away R is that. That guy is not the right answer as far as I'm concerned, and hopefully as far as WebAssign is concerned. You should never leave fractions with fractions in them. So what you can do is multiply by a special version of 1, in this case pi. Would you agree multiplying something by pi over pi is just multiplying it by 1? Now if you take the top guy, you now get 6, and that guy gets you pi, and that guy gets you 1. Do you see that's a much prettier answer than it was a moment ago? And that would be the one that I'd expect you to do. Are we cool on that? Right. So we are on geometric series, but we are in less obvious places. Now, I'm not going to do this next question all the way through. I'm just going to do it suppose I had that, and I'm told that it's a geometric series, so I don't need to worry about if it's not or not. If I had this one, again, it's not obvious who A is, and it's probably not that obvious who R is. So what I would do is I plug in 1, and I get positive 4 over 3 cubed. And then the next one would be negative 1 over 4 squared over 3 to the 4. And the next one would be positive 4 cubed over 3 to the 5, and so on. And have you noticed I haven't bothered to turn them into 27s and 81s? Right. So if you plug in 1, you'll get that guy. If n equals 2, you get that guy. N equals 3, you get that guy, and so on. Now, I know who A is. Isn't A the first term, which I will now call 427s? And won't R be A2 divided by A1? In this case, it's negative 4 squared over 3 to the 4 divided by 4 over 3 cubed. And then what you go and do what you need to do, and you're done. Any questions about just uglier and weirder looking geometric series? Ones where they're, in a way, kind of hiding the A and the R value from you. But you should be able to get them. If all else fails, just write the terms down like I have. First one is A, and the 2 divided gets you there. Any questions? Is that a geometric series? Yes or no?
Yes.
Yes.
Agreed. That question didn't tell you. So they're now going to give you guys, and they don't tell you. Right? How do you know it? You're right, it is. How do you know it's a geometric? What was the clue in your brain?
It's increasing by a common ratio.
Pretty much. Do you notice it doubling 9 times, right? Bang on. So can't you get A and R out of that the usual way? So I'm not going to do any more. Here is another one. Goes on quite a bit, but they don't tell you what it is. Is that a geometric series? Correct, it's not. Would you agree it's not got a common ratio? Essentially, aren't you just adding 1 to the top and adding 1 to the bottom, right? You're not multiplying at all. But we still have to solve the problem of, does it converge or not? Well, does it converge or not? Well, that's a question that we need to answer. A1 is a half, A2 is 2/3, A3 is 3/4. What would the general term AN be? So we're trying to create a formula for the nth term here. That's how I would approach this question. Okay, The first guy is 1 on the top, the second guy is 2, the third guy is 3, the fourth guy is 4. What would the nth guy be on the top?
And
And what would the guy underneath be?
that would be n+1.
Do you all agree on that? I know we haven't done a lot of them, but didn't we do some practice creating the formula for some guys? This is a case where that happens. Now, do you notice what happens to this fella as n goes to infinity? Isn't the limit 1? Don't we have a test called the divergence test? And the divergence test says if the limit of the individual sequences is a number and that number isn't 0, which in this case it clearly isn't, then won't the series diverge? So that's how solve that question. Right, remember the divergence test? It was the first test we did, I think it was yesterday. That is definitely not a geometric. Let's do the divergence test on it. I guess they've decided to use K just to be a different letter of the alphabet. Do you notice what the limit of that is as K goes to infinity? What is the limit of that expression, the individual terms, as K goes to infinity?
Half.
Say it again. I think you said it right. I just didn't catch it, Matthew.
A half.
A half. Couldn't you divide top and bottom by K squared to prove that to me? Or L'Hopital a couple of times? Since it is a half, does that mean this converges or diverges?
Converges.
Oh, you're thinking because it's less than 1, aren't you, Stefan?
1 at diverge.
It will diverge. The divergence test is different from the geometric series. In the geometric series, you'd be quite right. If the answer a half came out, you would say, oh, the common ratio is a half, it converges. But when you do the divergence test, as long as this is any number in the universe except 0, it diverges. And so it diverges.
I had mixed up the K and the squared. I read 2 to the power of K on all of them.
Okay, we don't want to do it, but if you did. How about this one? I don't need to know the details because there's a lot going on here. But how would you tackle the question of does this converge or diverge?
Couldn't you break the 6 to the n-1 into a 6 to the n and a 6 to the -1, and then combine the 5 and the 6 to the n with a 1/6 at the front?
And essentially write it more like a geometric series?
Yeah.
Yeah, that would work. Not everybody would find that a very direct approach, but none wrong with it. It would work.
You could also rewrite it for L'Hopital, I think.
Oh, no. If you
Okay.
tried L'Hopital, and that would be
Oh,
bad
wait.
news.
Oh yeah. Sorry.
Right? But what you could do, couldn't you just plug n equals 1, n equals 2, n equals 3? By the way, do you recognize that that actually ends up being a geometric series, even though it doesn't look like one? It ends up being one. So if you were doing that question, just plug in n equals 1. And so what you'd get is 5 times 6 to the 0. Then you get 5 to the 1 times 6 to the 1. Then you get 5 to the 2 times 6 to the 2, and so on. And it is a geometric series. And A is the first term. Well, 6 to the 0 is 1, so the first term is 5. And the common ratio would be that guy divided by that guy. And you'd be able to tell Hopefully you can tell that that actually diverges. How about this fella? Right now, there are only 3 tests in the world. You can do it with a divergence test. You can do it with a geometric series test, or you can do it as a telescoping series. That's the only 3 we know of. There's more to come, but right now, that's the only 3 guys in town. Which of these 3 tests do you think, by the way, that's e to the negative n, in case you're wondering, should I use?
Is it telescoping?
Because it's a fraction and you're hoping you could maybe split it into 2. Is that your kind of thought
Yeah.
process? Yeah. I know it's not, but I can imagine why you would think that. But there really isn't any partial fraction I could ever think about that would work with that. So I would probably ignore that one as a choice because of that. I can imagine in other situations, fractions do very often get you them, but they tend to look more like this, don't they? You know, they tend to have 2 bits in the bottom rather than 1 if it's going to be a telescoping series. So that's probably, I can see why you picked it with it. We'll cross that off our list. Okay, 2 guys to go.
Would you usually default to the divergence test? Because it's like easy to find a quick limit, and at least it won't tell you everything, but it might tell you at least divergence. And then
That's
you can
what
work on harder stuff later.
That's what I do, Kira. I just try a divergence test right away. It's not hard to do, right? Can you imagine just saying what happens when n goes infinite? And if the answer comes back as a number, right, a half, a 4, a 3, I'm finished, right? Divergence. And if it doesn't, well, okay, I've got the next guy to do, so let me do that. The limit as n tends to infinity. So if you're looking for a strategy here, how about, just like Kira said here, how about do a quick divergence test, even if it's only in your head, and check that one out. If that one works, you're finished. Now, in this case, brute force is going to do it. But people have problems with powers that are negative infinite, all right? Because they'll look at that and they might say, and I can understand why, that that is infinity. But that's not actually what that is equal to. Isn't a negative power the same thing as that guy? Now, if I look at it in that way, isn't it now 1 over infinity? But 1 over infinity gets me 0, and bingo, it diverges, because isn't its limit a number that's not 0? Now, if I do get 0, right, if that ends up being a limit and its limit is 0, then the divergence test is inconclusive and I go looking for somebody else to help me out. Right, got a couple of more to talk about. They're getting even uglier as we move down. So this is in the 28, 29 world, stuff like that. And here's our first one. Looks something like this. Any suggestions about how you would tackle a question like that? First time you've seen anything that even vaguely looks like that? Any suggestions?
Geometric series.
Well, if I split it into 2 pieces, you're right. Can you trust me that that's a geometric sequence, but you're going to have to write down some terms, you know, the first one, second one, and you're going to find out eventually, I believe, that that one converges. And this guy here, not really a method. It's just that you've got good memory. If I pull out the 4, do you recognize that guy? We did it. It even had its own name that started with an H. It was called a harmonic series. What does a harmonic series converge or does it diverge? And I gave a kind of pseudo proof when I showed you that.
Didn't you say it diverges?
It does. So this guy here diverges. Now here is an interesting feature. This series is made up of 2 pieces. This one, just like someone said, is a geometric, and actually you'll prove that it converges. This piece diverges. What happens to a series that's made up of 2 pieces, one that converges and the other piece diverges to infinity? What does the overall, the combined series do? Because it has to do one or other. It can't do both at the same time.
Diverge.
Right. And I describe this as if one bit's broken, the whole thing's broken, right? So if I was wanting to save some time, wouldn't I have just focused on that piece and said it diverges? And I don't care if that diverges or converges. Once that's broke, the whole thing is broke. Broke means diverges in my language. How about this one? The first part I'm going to do without asking, because this is what you should do in all these situations, is if your series is made up of clearly 2 distinct pieces, do each one separately. Right. What's this one going to look like?
Geometric.
Right. Won't you have to write down the first couple of terms to find out who A is and R, but it's geometric and it will converge, but you'll have to find that out. And it'll converge, so it means it's equal to something. You should be able to calculate its sum. Do you recognize that guy?
Telescoping.
Right, and won't you have to do partial fractions, cover up method, and off you go, and that one will converge. And I'm making this up. This converges to 1 over e squared, and this converges to a half. So won't the whole thing converge to 1 over e squared plus a half, if that's what it really was? And you probably won't be able to do any style points in that, so just leave it alone.
Would the common ratio for the 8 over e to the power of n be 1 over e? Would that be right?
Oh, I like that, Stefan. Yes. Now tell me why. Why? What were you noticing? Because it's true in every question that we've done that would be the common ratio.
Because you're trying to multiply the e, but not the 8. So
right,
just...
the 8's fixed, so you can forget about it. Right? Ah, very good thought. Yeah. So based on what Stefan's just said, if I was only interested in the common ratio, I don't even care that these are different powers, because that kind of sorts itself out in the wash. I can look at that and tell you the common ratio. Suggestions. What would the common ratio be for this one? Pretty straightforward. There's nothing sneaky about it. It's actually very straightforward once you see it. Eight-thirds. But what about that n plus 2? That's different. The other one's an n. Doesn't that make maybe 3 cubed in the bottom? Does it do stuff like that? No. That sorts itself out. If you wrote it down the long way and did a2 divided by a1, that sorts itself out. Suppose that was n minus 1. Would make no darn difference. The common ratio would still end up being 8/3. What would change is the a value, right? The first number. right? Because if that was an n or an n minus 1, do you see that the a value would be distinctly different, right? But the common ratio doesn't really care what the powers of each of the numbers are. You know, from one number to the next, you're still going to multiply by 8/3. And that's what the common ratio finds. The a value will be, you know, more important. That does depend on those terms. So that was a good point. Somebody noticed. We have time for a fun question. Tell me a 2-digit number. Anybody? 2-digit number.
26.
Okay. The repeating decimal 0.262626 forever. I would like to know what that is as a fraction, a ratio. And you might think, well, I don't know how I'm going to do that. Well, here is how we do it. I recognize that I can do it as a series. Do you recognize that this guy is A? And isn't the common ratio 0.01? Check that out. Could be another 0 there. So 0.0026 divided by 0.26, 0.01. This is a geometric series, or at least it was created from a geometric series. And it converges, as I know. And it's A over 1 take away R. This is actually similar to the last question. It's a 0.2 over a 1 take away 0.01, which is 0.2 over 0.
Isn't it 0.26?
Thank you. By 0.09, right? 0.99, 1 take away at 99, and 0.26 over 0.29. If I multiply by special version of 1, in this case 100, hey, I have just created a fraction, 26/99, that is the same as that guy. So I guess I should check it. Is 26 divided by 99 0.26 repeating forever? Yeah, it is. That particular fraction, I don't think simplifies, but can you imagine you might get a fraction where you could cancel it down a little bit so it won't be quite the same. Yeah, that's just a little fun question to finish with. Right, say your last names and bye-bye, guys. I've made a change to when online test 1 is due. It will now be due around about 1 p.m. today. Most of you, that will have no effect because you weren't going to do it then anyway, but it's for the benefit of some people who asked me to put it a little bit earlier. So you can still do it on Saturday. You can still do online test on Sunday. I suggest strongly that you only do it after you've done all the homework and have had plenty of practice, but it will appear today at 1 p.m. rather than Saturday morning, as I originally said.
But
All right, I actually have 3 questions.
Oh, cool. 3. Go for it.
Yeah, okay, so the first one would be the problem we did with the 5n multiplied by the 6n minus 1.
That one?
Yep.
Okay, so I'm just going to write down the first 2 or 3 terms. So when n is 1, you get 5 to the 1 times 6 to the 0. Then when you plug in 2, you get 5 squared times 6 to the power of 1. And one more just for luck, 5 cubed times 6 squared, and it goes on like that forever. We're good with that.
Yeah.
And
I was just confused because I wrote down 5 to the 1 times 6 to the 0, and then 5 to the 1, 6 to the 1, and that was confusing me.
Did I write that down? Because if I did, I screwed up.
I don't know. Maybe it was just me.
Okay. And are you good now?
Yes, with that
Okay.
one, yeah.
Right. What's the next one?
So the next one is, I just didn't write down the work in time before the page left. So
Okay, what was it?
it was the one with the 6 divided by pi to the n.
Okay, hunting for it. Of course, I haven't thrown these ones away, so I should be able to find it relatively quickly. Here we go. So the common ratio ends up being 1 over pi, which is why it converges. And then a over 1 minus r is a is that guy, 1 minus r, which is that guy. And that's a really ugly answer. And so to do the style points, I just multiplied it by a special version of 1, in this case pi over pi. And that gets me 6 on the top and pi minus 1 on the bottom, and that would be the best looking answer you could get. So this one converges to that.
Okay. Would we, on a test, would we get marked down if we did the denominator separately? Like multiplying it by the 1 by pi over pi and then doing it like that?
I'm trying to think what you're saying, Maggie. So would you still get this as the final answer?
Yeah.
Then you're fine.
Oh, okay. Wonderful. And then I had a third question. Oh, it was the same thing.
What's connected to this one?
No, I missed the, I
Oh,
did the work
okay.
and then,
Right. So yeah, I was a bit quick at the end because I wanted to cover everything that we had. So that's my fault, not yours. So which question, what did it look like?
7 log n minus 7 log n plus 1.
Gotcha. Do you mind if I keep this as part of the video?
No, I don't care.
Okay. Because the chances are that there's other people who didn't quite catch the end of something as well. I think all these pieces of paper, one of them. It's probably going to be the last one I look at, right? There we are. There it is. And then it kind of drifts over to here. Now I pulled out the 7 and then I changed my mind and put it back in because I thought people might get a little bit confused if you pull a sigma, but you're allowed to, if it's, as long as it's a fixed number, right? As long as it's a constant, you can pull it out of the sigma. Sometimes I find that helpful because it makes what's left a little bit cleaner, easier to deal with, but you can use it, and I did. Right, so we plugged in 1, plugged in 2, plugged in 3, as many terms as we feel, plugged in the last one, and then we did, that one survived, that one died, that one died, everybody dies, and because everybody dies, whoops, 1 at the beginning lives, that means 1 at the end will also live, and that's why these 2 terms are the only ones that wouldn't be killed off in this telescoping series. And if you take the limit as n tends to infinity, that guy's 0, and that guy's infinite, and so the answer is negative infinity, which is a diverging situation.
All right. Gotcha. Thank you.
You are welcome. Have a nice weekend. So how long's your sister Emma going to be hanging around with you?
Well, this is actually her last week. So she's going down Sunday night. And then in a few weeks I have to go down, so I'll see her then.
Oh well, so are you going to go anywhere nice, or are you just hanging about in the house?
This week?
Yeah. Are you going to go bowling or ice skating or?
Yeah, so actually we're going to go to OC to get my ID because I still don't have it, but I am taking an in-person class this quarter.
Okay, so you need
So
to
I
get
need
all
it.
that, and you'll also need your vaccination card,
Right.
because the COVID Gestapo might stop you and arrest you if you're not careful.
Do you know how they're doing that? Like, is there a place I have to go to check in before they'll let me on?
Yes, I believe, don't quote me because I work totally remotely, so I haven't been myself, but I believe that if you go to Do you know the building where all the good stuff happens? Finance happens and records and reg. You've got the library and it's whoops, and the building next to it.
I've never been on campus.
Oh God, I didn't realize that.
Or
Okay.
I have once, because I did meet you because I went to one of Emma's classes. So like that was the only time I've been.
Right. Well, Emma knows where places are because she's been before COVID, right? So it's going to be the building to the right hand side of the library. I wish I could tell you its name, but it's the building that you do finance, you get records and reg, and a lot of English classes are in it, if that's any help to you. And you'll probably see a big sign saying register here or check here, and you go in there. Just in case I'm telling you a lie, not deliberately, if you go to OC, you can do a little search and do something like COVID restrictions or something, and it may tell you, because it's possible, I'm not saying it is true, but it's possible what you need to do is do a photocopy of your vaccination and send it through email to them. And that way you don't come on campus unless they want you to and they know that you're allowed to.
Okay.
But you will need a mask, I can tell you that.
Yeah, they updated it too. So.
Yeah, so you can't wear all the fancy ones with Mickey Mouse and things. You have to wear those really boring ones.
Yep.
Yeah, a pain in the butt that is. Well, hopefully one day, before I drop dead at least, that we'll this COVID nonsense will be over with and we can start living our lives again.
Yep. Do you know if you'll be teaching the next calculus class?
Yes, I think I'm teaching Calc 4.
Okay. Yeah, I had a rumor that you were like the only person on campus who could teach it because what was his name? John White? Was that his name?
Joe White.
Joe White? Someone told me he left, so I don't know. I don't even know if that's true.
I don't know. I have not heard that. I'm surprised. If it had happened, I would have heard it, but I have not heard that. But he's not the only person that can teach it. There are other people who teach it, so it's not like the college. So if I decide to go to Hawaii and quit early, there'll still be people here.
Why would you go to Hawaii? I thought you would.
I want to go to. Yeah, but I want to go to Hawaii as well, and the weather in Hawaii sounds really good, so that's why.
Ah, okay. All right. Well, thank you so much.
No problem. Bye-bye.
Bye.